Hello, welcome to lesson 14 on the concept permutation and combination. Let me begin this lesson by giving you another very good application of the concept that we have been discussing. This is another very good example, okay? Please listen to this carefully. There is a network of horizontal and vertical roads as shown in the figure. I hope you are able to see the figure. There is a network of horizontal and vertical roads as you can see in the figure. A person has to go from A to B taking the shortest path, right? Somewhere we have read that the shortest path is the diagonal. Here there is no road that passes through the diagonal. So a person has to by default take a vertical road and a horizontal road and a vertical road to reach from A to B, right? And we are saying that we are talking about the shortest path. So you will not come back. You know what is the shortest path? The shortest path is something where you will keep moving towards B starting from A. That is the shortest path, right? Now what is the question? The question is how many different paths are possible? How many different paths are possible if somebody has to go from A to B and the path has to be the shortest? Okay. Now, when students get a question like this, most of us start thinking in terms of a hit and trial. You know, I start the question by saying, okay, let me just see. One way is the person can go straight like this and then reach B. The second is the person can go like this, take a vertical path, then a horizontal, then a vertical path. You can start this way, but very soon, within a minute or so, you are going to realize that this is not the way to solve this question. Alright? The hit and trial approach is not going to help you. Correct? Alright. Is there a way to solve this question? Right? Please listen carefully. Suppose this is a horizontal path, this is a horizontal path, this is a horizontal path, and this is vertical. Now please appreciate, for a person to go from A to B, this person has to take 4 horizontal and 4 vertical. 4 horizontal paths and 4 vertical paths. You know, somebody said that this is possible because you are going along the boundary. You go in between, you go using the middle paths, and you will not be able to reach B using 4 horizontal and 4 vertical. Let's see. Suppose I take an alternate path, vertical prime, then I take vertical prime, I decide to go horizontal prime, again horizontal prime, I feel like horizontal prime, I take a vertical prime, I take a horizontal prime, and I again take a vertical prime. So how many verticals? 1, 2, 3 and 4. And how many horizontal? 1, 2, 3 and 4. Irrespective of the path that you take, you have to necessarily take 4 horizontal and 4 vertical. Now let me tell you something. Take a horizontal path and put it here. So I'll have horizontal, 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 vertical, 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 and then a horizontal. It's a different path. Let's do one more thing. Take another horizontal and put it towards the end. I will have 2 horizontals, 4 vertical, and again 2 horizontals. Another path. I don't know whether you are able to understand what I am trying to say, but the number of paths to go from A to B is same as the number of ways of arranging these 8 things. What are you trying to do? You are trying to arrange these 8 things in a straight line, and out of these 8 things, 4 of them are called horizontal, identical, and the remaining 4 are called vertical, identical. So what is my answer? You can find out the answer to such questions in a single step. 8 factorial, 4 of them are identical, so divided by 4 factorial, 4 of them are identical, so divided by 4 factorial. You know, a student who knows this concept is able to solve this question maybe within 10 seconds, 15 seconds of having looked at this question. That's it. Okay. Another very good application of the concept of arrangement of things that are identical. Alright? Okay. Now, let me tell you another beautiful application of the same concept. But to take you there, I have to tell you a concept of permutation and combination, which is called as distribution, right? So we will start with distribution and eventually we will reach the application of that concept. It's beautiful, it's a very, very important application. Alright? Distribution. In distribution, I would definitely like to talk to you about 2 things. What is the first one? The first one is different things to be distributed into different boxes, or different things to be distributed into different boxes, Let it be this way. Alright, let me give you an example. In how many ways can we distribute 4 different prizes to 3 children? Any child can get any number of prizes. Okay, so what is the question? In how many ways can we distribute 4 different prizes to 3 children? Where what is the condition? Any child can get any number of prizes. So ideally what we are saying is there is no condition, right? Now this is called as distribution, and what are we saying? Different things to be distributed into different boxes. Please understand how do we solve this? Very easy. It is very easy. Okay. Imagine this marker is a prize. This marker is a prize which is to be distributed. So I have this prize in my hand. How many children I have in front of me? I have 3 children in front of me. So this marker can be given to any of the 3 children. So the first prize can be distributed in 3 ways. Once I distribute the first prize, what about the second prize? I have got another prize which is different from the first. How many children? Again 3 children. Any condition? No condition. So this prize can again be given away in 3 ways. In how many ways can I give away with the third prize? The third prize can again be given away in 3 ways, and the fourth prize can again be given away in 3 ways. Very simple. So in how many ways can 4 different prizes be distributed to 3 children? The number of ways is 3 to the power 4. Now let me tell you something interesting here. Something that we have seen over a period of time when we teach children in the classroom. Many students, you know what they do? They try to memorize this. They say, okay, I know that the answer to this question is in the form of x to the power y. Right? So that is one way to remember. The answer to such type of questions is usually x to the power y. You know something? The examiners are very smart. What the examiner does is, the examiner will give one option which is 3 to the power 4 and the second option which is 4 to the power 3. And suddenly I am confused. Because I did not memorize it that which one was raised to what power. I just memorized that it is something in the form of a power. So when I get something like 3 to the power 4 and in the same question I get an option called 4 to the power 3, suddenly I am confused. So what is my suggestion? Please don't try to learn the answer. Very simple, be logical. First prize can be given away in 3 ways, the second prize can be given away in 3 ways, the third in 3 ways and the fourth in 3 ways. Alright? Okay. Now let me give you another example of the same concept. Let me give you another example of this same concept. It's a very, very good example of the same concept. Okay. So what is the question? What is the example? The example is like this: 4 prizes to 3 children. 4 prizes, or let me change it. Now let me say 3 prizes to 4 children, such that exactly two of them do not get a prize. Okay, so I have an additional condition. 3 different prizes have to be distributed to 4 children such that exactly 2 of them do not get a prize. What is the logic? What should be the thought process? Step-by-step approach. First of all, let us say which 2 children are going to get the prize. So 4C2. What is 4C2? 4C2 is nothing but saying which are the 2 children out of the 4 who are going to be given the prize. So 4C2. Right? Now, once we have identified the 2 children, now the 3 prizes have to be distributed. Correct? Okay. So what did we learn? The first prize can be distributed in 2 ways. The second prize can be distributed in 2 ways. And the third prize can be distributed in 2 ways. Now, many of us make the mistake of saying that the final answer to this question will be 4C2 multiplied by 2 to the power 3 or 2 cube. This is wrong. Okay, this is wrong. What is the mistake? The first prize can be given away in 2 ways, looks fairly alright. The second prize in 2 ways, the third prize in 2 ways. Right? There are 8 different ways. We all know this. Let me write down what are those 8 ways. A, BC, B, AC, C, AB, AB, C, AC, B, BC, A, ABC, 0, 0, ABC. These are the 8 ways. 2 into 2 into 2, 1, 2, 3, 4, 5, 6, 7, 8. Now please look at these 8 ways. Out of these 8 ways, and I hope all of you are listening very carefully, right? Understanding. Out of these 8 ways, there are 2 ways in which all the 3 prizes will be given to only one person. And these 2 ways are not acceptable. Out of these 8 ways, let me repeat, out of these 8 ways, there are 2 ways in which all the 3 prizes is given to one of the 2 children. Now you will ask yourself, or you may like to ask me, why is this not acceptable? Because it says exactly 2 of them should not get a prize. In both these cases, 3 children will not get any prize. So, out of the total, these 2 cases have to be subtracted. So, what is my final answer? My final answer will be 4C2 multiplied by 2 to the power 3 minus 2. Alright. So, this was the concept of distribution, where different things were distributed into different boxes. We will see the second part of this concept in the subsequent lesson. Thank you.